Yeah, so Michael really told me to tell you to send his best regards. He's very unhappy not to be able to be here because his quite strong ties from the past with OEA, but also with LOPEC. So he would have loved to come here, but well, not this time. On the positive side, this gives me the chance to present to you Merck and represent Merck here on this great stage in this great conference. And it's about OLED, but not only about OLED, as you will see. So who are we? Who is Merck? Some of you might not know us. We are a global company, in total 50,000 employees worldwide. We have 20 billion of turnover last year. The part I'm talking about here is electronics. So we coined that new let's call it brand name about 1.5 years ago for this one sector of Merck. We have two other sectors, which is life science and healthcare. Not talking about this today, we are talking about electronics. More specifically, we will be talking about display solutions. But before that, a short glimpse on the business field semiconductor solutions, where we are, I think, a very meaningful provider for anything you might need to process and make integrated circuits, but also from the material side, but also from the delivery, gas side, and specialty chemicals. On the surface solutions side, we offer pigments. These are decorative pigments, but also functional pigments. The main industries we are selling here is automotive, cosmetics, and also industrial uses. And the part I'm going to focus on here today is display solutions, where we drive basically the whole display industry with our materials and services. And yeah, I think, I hope you will see what this is about in the next slides. Merck itself is 350 years old. I think that is not an achievement in itself, but it tells us that we have also reinvented ourselves in the past. We are still family-owned by 70%, so that brings a certain perspective to things, which is perhaps a bit unusual in this industry. We always had a big focus on innovation. I hope I can prove to you today that we always are very active in developing new materials, new technologies, new services to, let's say, advance our customers' business. Quality is, of course, very important. There's no innovation without the ability to scale up materials, also with the right quality and a constant quality. And I think our world-class analytics is part of that promise. I think, and I'm only going to present you a small glimpse of our portfolio, but I think it's really very broad in the display industry, but also in the other sectors we are working in. And this comes together with a, let's say, very global footprint. So our logic always has been to be very close to our customers, which means close in terms of mindset, but also close in terms of proximity. So as one example of this, already in the 80s, we introduced and built our first research center in Japan, Natsugi, for liquid crystals. And just to show this here, so these are the Merck electronics sites worldwide. As you see, Darmstadt here, where I'm based, as the headquarters, the central hub, but also a strong base in the US, which is mostly linked to semiconductors. But then a big part of this, of course, in Asia, where a lot of our customers sit. And we also have our research centers in Japan, in Taiwan, in Korea, and also in China. So moving in to displays, there are several, let's say, materials which we offer, or materials classes. Perhaps most well known is liquid crystals. We are a market leader here, I think also innovation leader. We have really constantly introduced new materials, new technologies into this industry, which I think really made a change and helped this industry advance over the last years and decades. OLED materials, I'm going to dig deeper into this also today. So here really it's offering kind of a revolution in display. How far this is going to be kind of in competition with LC also, I'm going to look into this. We offer photoresists. In this case, these are not the ones offering the super high resolution for integrated circuits, but it's the one you need for making a backplane, which is also an art in itself. We offer reactive mesogens, which are basically polymerizable liquid crystals that you can make really ultra-thin coatings with exciting optical properties for optical films, for displays, but also beyond. We offer siloxanes, coatable dielectrics, and also quantum materials, which become more and more important also in context of displays. Today, the focus is more on the left upper side, so it's OLED materials and also LC materials, but not for display applications, as you will see. But first, going for OLED. So here, there are several drivers for this market. The first is TV, and I think you all know that TVs are around. Let's say the biggest, and I would say until recently only, technology here is white OLED. So you have a white OLED stack plus color filters. I think beautiful displays, very successful. Now we've got a, let's say, additional competing technology, which is QDPCC, quantum dot pixel color converter by Samsung, where basically also have a blue OLED, but also have then color conversion in the color filter layer. And also inkjet printing is aiming for that market. It's not there yet, but yeah, there to come. Smartphones, I think, were the, let's say, first entry of OLED displays into the market. It's really driving the growth here and also offering really better and better displays, which links itself to the next topic, which is the foldable, which is, I think, a lot about smartphones, but not only. Also, LG has presented rollable TVs in exhibitions. I think they're also beginning to sell them now. So it's really exciting here. I'm going to present something on this. And what we have also seen is that OLED is basically also filling that size gap, because it starts at two ends, so to say. It starts in the smartphones, which is RGB, and also at the TV, but there's quite a big gap in sizes in between, which are actually difficult to make. But also here we see that also OLED RGB displays are growing bigger. We see tablets and notebooks on the market. I think it's no secret that also the next or second next generation iPad will be an OLED display. So I was actually quite surprised when I saw this number, because you always think, oh, OLED TV is there and it's gradually replacing LCDs. Well, it's there, but not to the degree that you might think. It's at the moment, last year, only 4% of the total display area of TVs actually are OLED technology, the rest is LCD. So on the good side, for Merck, this is not really cannibalizing the LCD market for TV yet, I would say. But this also means on the positive side for OLED that you see basically a lot of room to grow. And what the market analysts say, we are looking at something like 25% annual growth rate for OLED TVs in terms of size. So perhaps remember that number, 7.8 square kilometers of TV displays are manufactured or were manufactured last year. What do we offer here? I'm not going into the technical details here, and today we offer a wide range of materials, of transport materials, both on the electron but also on the hole side. That OLED stack is quite a complicated animal, I would say, where you really have to tune each and every layer to the whole stack. We are also offering materials for the emissive layer, which is, first of all, pre-mixed host materials for the green, but also we are entering the market with our proprietary concept for emitters. We call them cage-type phosphorescent dopants for green and also yellow. Now looking into the smartphone market, which has been there, I think, for a longer time than TV, you see us has been really nicely growing over the last years. We saw, I would say, before COVID, we saw something like 26% annual growth rate from the years 2015 to 2020. But then really you see quite a dip caused by COVID, where basically this market didn't grow from 2019 to 2020. But then looking to the future, we see projected nice growth, annual growth at about 13%. And what you also see here that not only the total, let's say, area is growing, but also the penetration of OLED in that market is growing. Remember the numbers, so it was 7.8 square kilometers in 2021 for TV. Here you see it's 5.8 square kilometers OLED displays for smartphones. So already overtaken, but of course in terms of numbers, of device numbers, this is much bigger. Penetration is about at a third now, a good third. Projected to grow, and of course I think that is also causing that number, the 13%. It is slowing a bit because it's already at a high penetration rate. One very interesting segment of this is foldable displays. Also, Mr. Mildner mentioned this. Yeah, it's really an exciting area. At the moment, we see only a really small portion of the market is foldable of the smartphones. Is about 1% last year projected, 3% last year, 5% projected this year in terms of size, so in terms of area, which means in terms of numbers, even smaller. But it's projected to grow really rapidly at 63% year on year. So this is really impressive, and these devices are already really quite impressive. So Samsung is now at the third generation, and I think they have quite a steep learning curve. But this also means that I think in this market there's still a lot also to optimize, to invent, because I mean, as a final consumer, I think you may agree that it's nice to have a foldable display, but you're not taking any compromise in terms of display performance or scratch resistance or whatever. And this really raises the bar very high for the technologies you will need. So here also we have launched our LiveFlex materials, which target the, let's say, complex area of that encapsulation and also additional layer stacks. We are still, of course, active also here in the OLED stacks, but what I want to mention here, we are also offering materials for the thin film encapsulation, also for the cover film, stretch resistant yet bendable, and also we are looking into coatable polarizers which are needed for anti-reflection. So here, what is the truth is you have to optimize the whole system so that you really can achieve a bendable display which really has a long lifetime. And here we are more than happy to work with our customers closely, because I think you cannot just take this off the shelf and run and it will work. I think you really need a close collaboration, and I think we have proven we are very good at that. The next slide is a bit of a jump in topic. You might be surprised how I come from bendable displays to dynamic glazing. I think you will see the connection later, because this is at the end about display materials. This is a liquid crystal technology. So what you see on the left-hand side is a building which was built in, I think, 2020 by a company which goes into building automation, FC, by this architect 3 Deluxe. I think it's quite amazing, and it features really a large facade of dynamic glazing. And dynamic glazing, what can it do? It can tint by applying a voltage. So what does this mean? So basically, why do you have windows in the buildings? Of course, you like the views outside, but you also like the sunlight inside. But we also have shades, because we don't like too much of sunlight sometimes. But these shades have problems. So they are mechanical, they break, they are not, let's say, silent. Even if they're automated, they might move too slowly. So here I think there's really some room for innovation, and we hope and we think that this dynamic glazing will exactly fill that. This, let's say, improves the whole atmosphere in a room. Of course, it can also contribute to the energy energy consumption of a building by shading the insides from too much heat, for example. But what I also learned recently is that the main aspect of sustainability in a building, or the main CO2 footprint, is actually happening when you build it. So the more you use the building, the better for the building. And making or enhancing the well-being of the users of the building is certainly a strong contribution to its CO2 footprint. How does it work? And this is where liquid crystal comes into the game. It's a liquid crystal technology. It's a cell filled with liquid crystal, which also bears some dye molecules. And in the state where you have the voltage applied, they take a certain direction, and daylight can pass through the window. When you apply voltage, you take off the voltage, they relax into the shaded state, so the molecules basically move with the liquid crystal, and you have a dark window. And this can be done basically not only in the two states, bright or dark, but also in any shade in between. The last technology might also surprise you a bit, and this is about satellite antenna. We have looked into, let's say, other uses of our big library of liquid crystals, and it turns out that they can not only modulate light, but also modulate microwaves. And here, basically, what you build is a phase shifter, and this phase shifter is built into an antenna, which can then track satellites, which is getting more and more important with low orbit Earth satellites, which actually are not stationary, but are moving. A very short glimpse. I don't want to miss out on this very last topic I brought to you, which is, well, a surprise, because after more than 100 years of liquid crystal science and research, actually, you can still have surprises. And this is this exciting ferroelectric pneumatic liquid crystals. They, I think, were, let's say, discovered 3 years ago, and we quickly had a look into our libraries and materials, and we could actually make very nice and room temperature stable materials or mixtures. And they have really exciting properties, huge dielectric constants, and so on. We decided to make this an open challenge, and you're very welcome to enter this and to contribute to this. Basically, it's about finding an application for these exciting materials, and as Richard Mendel puts it, it's almost impossible to imagine that these materials won't find wide application. So basically, I would say in my own words, it's a solution looking for a problem. So I leave you with this information, but not without getting a direct impression from this. And please forgive me the poor quality. It was taken in the lab basically by a mobile phone. But this is what you see here. So you take a pipette, this is the liquid crystal, you take it out, and actually you see that they follow the field lines. There's no tricks behind it. It's just the normal statics you have in the lab. And they do this kind of hedgehog-like following the field lines. So that I find this really fascinating. When I saw it in the lab, I couldn't believe it, actually. So, which brings me to the end of my talk. I hope I've proven to you that innovation is at the heart of Merck and keeps you ahead. And yeah, I leave you to the rest. But I'm also saying that these colors were not chosen by chance. Thank you very much.
Thank you. Thank you, Dr. Bernatz. Are there questions?
Just one question. You talked about these new materials, and I'm a printer. Has anyone tried to print them? Or will it be possible?
I think it might be quite challenging, as you see, because they behave very awkwardly. Yeah? So I think you will have problems with static and so on. Yeah? But I'm sure that there are techniques you can find to print them. But then I think that the next challenge is rather to find the fitting application, and then how you then get them into this application. I think that's, of course, the next hurdle you have to take. At the moment, not our biggest worry. But thanks a lot for the question. Yeah, I'm sure that printing will play a role in also making those final devices.
Maybe I can add on with one printing question as well, also for the OLEDs. How do you consider soluble OLED materials? Is that something you will put into production. Is that already started, or how do you see that?
Yeah, so Merck is active in that field as well, as you might know. I haven't put it into this presentation because I want to focus on more, let's say, close to market, already commercialized technologies and materials. I think it has been around for quite some years. Not really, let's say, large-scale commercial yet, and there are some reasons because really the bar is very high. So it's really a huge challenge to make such devices and even displays. I think it's here to come. The question is when, and the big challenge here is I think that's a moving target. So the rest of technology, like OLED vapor, is advancing at quite a high pace, but this is not saying that there might be not softer entry points, especially in the mid-size, which I mentioned in the beginning, for panels. So here, yeah, let's wait and see. It's going to be exciting. Yeah.
Okay. With that, I would like to thank Dr. Bernatz again. Thank you for stepping in for Michael Heckmeyer. All the best for you and for him, and also for the development of further OLED. Thank you.
You're more than welcome. Thank you.